Okay, what we want to do with this particular file is see what we can discover about the relationship between the linear factors of a function and the graph of that function. You'll notice that we've got here a 5 different polynomials written in factored form here, numbered 1 through 5. And off to the side we have a graph, and it says the first one is done for you. So this graph right here is number 1, which is the quantity x plus 1 times the quantity x minus 4. Now how do we know that that's it? Well, if we come over and look at our data here, if I click on this, you'll notice that up here in the formula bar, we end up seeing B3 times F3. Well, B3 is this, x plus 1, notice that's the same as here, times F3, which is this cell, and you'll notice that it's right below the x minus 4. Okay, so they've taken the x plus 1 times the x minus 4, and if you'll notice those two factors, and you come down here and look at the graph, is there anything that you can see about the graph that has anything to do with the factors x plus 1 and x minus 4? As we look at those, can you see any kind of relationship? If you can't, let's move on and explore, or even if you can, let's move on and explore number 2. Now to get number 2, here's what we're going to do. We will go up to our formula bar, and you'll notice this time we've got x minus 1 and x plus 3. So up here in the formula bar, I'm going to change those two. We want x minus 1, so I'm going to come down to the x minus 1 column. I'm going to click here, and then I want to go times, that's what it means when there's two parentheses together, times, and then we see down here an x plus 3, so that will be the g column function. So I'll click here and I'll hit enter. Now that changed my value up here in this line, but what I need to do now is double click this with the little crosshairs on the lower right hand corner, and notice that all of my values changed, and at the same time below our graph also changed. So as we look here at x minus 1 and x plus 3, is there anything that you can see that ties what we see in the graph to the factored form of the function? Some of you may have caught on. Let's just take a look at one more just to be certain that we've got the pattern going on. Up here I now change this to, we're going to change our formula. Number 3 below says x plus 2, that quantity. So that's going to be column D times shift 8. And then we want 2x minus 9 here. And so we come over here, and that's column H. I'll click here, then I will hit enter. Now to get that formula to fill down in our P of x column, I double click. You'll notice that not only did the y values or P of x values change, but so did our graph down below. And again, we'll take a look and say, what relationship is there between the x plus 2 and the 2x minus 9 that might give us a clue about what's happening. Now, be sure when in your exploration that you go on to the other 3 tabs, Poly 2. You'll notice this time there are 3 different factors. In Poly 3, we have 4 different factors each time. And so, of course, you'll have to click this times this times this times this, and then see what happens. Now you'll notice that on some of these polynomials, some of them have some factors that are repeated, and it will be important that you notice what happens when you see one that shows up twice, as in number 2 here, or one that shows up 3 times. So the multiplicity of the factors will also have a role in this. And then be sure that you go on to Polynomial 4 tab, and you'll notice there we've got even more factors, and in some of these, some of them are repeated more than once. And you'll want to note what happens when one shows up 3 times or when one shows up twice. And you can do that by transferring that information up to our output column, watching what happens when it changes the graph, and then comparing what you see in the graph to the factors, the linear factors off to the right. Well, good luck with your discovery.